Hello students, today we will discuss about the pharmacognostic study of Catechu and Pterocarpus. These drugs are comes under the category of the tannins containing drug. So first drug is the pale Catechu, which is commonly known as the Gambier, Catechu or Gambir. If we talk about the biological source, it is a dried aqueous extract which is produced from the leaves and young twigs of Uncaria gambier belonging to family Rubiaceae. Okay, its botanical name is the Uncaria gambier and it's belong to the family Rubiaceae, and its useful parts are the leaves and twigs. And about the geographical sources, this plant is native of the southeast regions like Indonesia, Malaysia, Sumatra, Borneo and Singapore. So you can see the leaves of this plant pale Catechu. So it is looking like this as shown in the picture. And next is the cultivations, collections and preparations of the drug. So commonly it is cultivated by the seed propagations method. So by this methods, for cultivations, normally these seeds are sown in the nursery to raise the seedlings, and after 9 months these seedlings are transplanted in the open field, and there should be distance between two seedlings 3 meters approximately, and the leaves and young shoots are collected as a first crop during the second year of growth. So we can say that when the plant is 2 years old, then at that time leaves and young shoots can be collected, and later on the crop is taken every year. So after completions of 2 year, first crop we can take after completions of the 2 years, and after that in each years we can take this crop, and the plant continues to give the sufficient leaves and twigs up to 20 years. So we can say that the plant can be give leaves and twigs up to 20 years, but maximum yield is obtained during the 8 years of the growth. So initially first 8 years are crucial in which the maximum yield we can obtain, but however the plant can give their crop up to 20 years, but most of the yield we can obtain during the first 8 to 9 years, or we can say in the 8 years. So these collected leaves and twigs are transported to the factory as a loose material. Then these loose material is put into the large drums with about 3/4 of the boiling water. So we will take these materials and we will put into the drums, and we will boil with the water. Then after that boiling is carried out approximately for the 3 hours with the intermittent stirring. Then the mark is subsequently removed by the large wooden forks and lodged on the surface to drain the liquor back to the vessels. Now it is pressed and followed by the washing. The washing is added to the extract. The combined total extract is then concentrated for 1.5 hours till it's become thick yellowish green paste. So this yellowish green paste is transferred from vessel to the wooden tubes, stirred with it while it is hot. So its transportations from the vessels to the wooden tubs should be when it is hot. During hot condition it should be transferred from vessel to the wooden tubs, followed by the cooling in a stream of water to crystallize the tannins. So because of cooling there will be the crystallizations of the tannins. Then semi crystallized paste is again transferred to wooden trays in which it's set. Then these are cut into cubes by wood knives, followed by the drying in the sun. Under the sunlight they can be dried, and they will cut into the cubes with the help of the wooden knife. And if we talk about the descriptions of the drug, so color is reddish brown, odor is odorless, taste is astringent, and shape and size, they normally occurs in the forms of the cubes or rectangular blocks, and the size may be 2 to 4 centimeter in length. and you can see that this diagram of the drug. So now if we talk about the chemical constituents, so catechin is the major active constituent, and its concentrations may be 7 to 33%, whereas other constituent is catechotanic acids, which is 22 to 50%, and it's also contain some catechu red, gambier fluorescence, and quercetin, and it is the structures of catechin. Now identification test of the drug. So first test is the gambier fluorescence test. So in this test we will take the alcoholic extracts of the drug, to which we will add little amount of sodium hydroxide followed by shaking with the petroleum ether. The petroleum ether layer shows the green fluorescence, and black catechu does not pass this test. So this is the difference between the pale catechu and the black catechu, and black catechu doesn't pass this test in green fluorescence. So we can say that gambier fluorescent test is not passed by the black catechu, which is the difference between the pale catechu and black catechu. Next test is the vanillin hydrochloric acid test. So in this test, drugs will show the pink or red color with a mixtures of vanillin, alcohol, and dilute hydrochloric acids, and the ratio of these all compounds should be 1:10:10. So we can say that vanillin, alcohol, and dilute hydrochloric, so 1:10:10 ratio will be there, and these reactions will produce the fluoroglucinols, which along with the vanillin gives the pink or red color. So because of this fluoroglucinol will give the pink or red color with the treatment with the vanillin. And another test is a matchstick is dipped in decoctions of pale catechu, is air dried, and again dipped into concentrated hydrochloric acid followed by warming near the burner. So pink or purple color will be formed. And in another test, so we will take the small quantity of the powder followed by heating on a water bath with 5 ml of chloroform followed by filtrations, and the filtrate is evaporated in a white porcelain dish on a water bath. A greenish yellow residue is obtained due to the presence of chlorophyll in the drug, and black catechu give this test negative because there is no chlorophyll present in the black catechu. So these two tests are differences between the pale catechu. First one is the gambier fluorescent test, and second one is this chlorophyll test, so in which we are taking the small quantity of the drugs, and we will heat on the water bath with a 5 ml of chloroform followed by the filtration. So we will evaporate the filtrate in a white porcelain dish on a water bath. A greenish yellow residue is produced because of the presence of the chlorophyll, and because chlorophyll is absent in the black catechu, that's why drug not pass this test. And these are the uses of pale catechu: normally as an astringent in the treatment of diarrhea, in dyeing and tanning industries, and it is used for tanning of animal hides to convert it to leather. So we can say that in the preparations of leather it is commonly used, in tanning industries, and for the dyeing purpose it is commonly used. Medicinally it is useful as an astringent and in the treatment of the diarrhea. Now these are this table is showing differences between the black catechu and pale catechu, and black catechu is commonly known as the katha or kach, whereas pale catechu is known as the gambier or gambir. And if we talk about the biological source, so black catechu is the dried aqueous extract which is prepared from the hardwood of Acacia catechu or Acacia chundra belonging to family Leguminosae. Whereas pale catechu is the dried aqueous extract which is obtained from the leaves and twigs of the Uncaria gambier belonging to family Rubiaceae. And in reference to identifications test, so these tests we already discussed that pale catechu is positive for the gambier fluorescent test, whereas black catechu is negative for this test, and another is the chlorophyll test which is positive for the pale catechu, in which it is giving the greenish yellow residue because of the presence of the chlorophyll. But in case of black catechu, chlorophyll is absent, that's why it's not give positive test for this test. And similarly, in case of gambier fluorescent test, so we will take the alcoholic extracts of the drugs, to which we will add the little amount of the sodium hydroxide followed by the shaking with the petroleum ether. So the petroleum ether layer will show the green fluorescence, and this test is negative for the black catechu. So these are the differences between the black catechu and pale catechu. Now regarding the method of preparations of the black catechu, so for the preparations we will take the separated hardwood in a boiled in earthen vessels, fired up by the sapwood, followed by boiling, continue till the soluble portion is extracted from it, then followed by cooling, due to which it convert into the semi-solid mass. And because of cooling, less soluble portion is separate out. Now the latter is removed as a katha and semi-solid mass as a kach. Okay, this less soluble portions is separate out, so it is known as it is removed as a katha, and whereas the first semi-solid mass we obtained because of the cooling, it is semi-solid mass which is known as the kach, whereas the less soluble portion is known as the katha. And then it is transferred to rectangular pits, at the bottom of which there is sand and clay are placed. So this drugs is kept for several days in these pits until the kach part is absorbed by the clay and solid mass is known as the katha, and it is taken out and molded into the blocks. So as per the requirement of the mold, we will use the blocks to make the molds as per the requirement. Now about the chemical constituents of the black catechu. So major active constituents of black catechu is catechins, which is distereoisomers of 5,7,3,4 tetrahydroxyflavone 3-ol, and it is also known as the acacia catechins. So what is the major active constituent? This is the catechins, which is distereoisomers of 5,7,3,4 tetrahydroxyflavone 3-ols, and it is commonly known as the acacia catechins, which is on oxidations with water it gives the catechu tannic acids, and it does not contain the chlorophyll. So because it is not containing chlorophyll, that is the reasons pale catechu have the chlorophyll, whereas black catechu doesn't have the chlorophyll. So due to this reasons it is not give the positive test for the chlorophyll content, as we discussed previously. And if we talk about the identifications test of the black catechu, so we will take the sample, and on treatment with the vanillin it will give the pink or red colors. And in another test, when we will treat the sample with the hydrochloric acids and fluoroglucinols, sample on treatment with the hydrochloric acid, so it will give the fluoroglucinol, which burns along with the lignin to give the purple or magenta color. Okay, when जब आप इसको हाइड्रोक्लोरिक एसिड के साथ ट्रीट कर रहे हैं तो ये क्या कर रहा है, फ्लोरोग्लूसिनॉल का फॉर्मेशंस कर रहा है. फ्लोरोग्लूसिनॉल्स जब आपका बर्न होता है लिग्निन के साथ तो इट विल गिव द पर्पल और मैजेंटा कलर. एंड नेक्स्ट टेस्ट इज द when we will take the aqueous extracts of the drugs and we will treat these drugs with the lime water, so we will obtain the brown color. and if we stand for some time, so this brown color will convert into the red precipitate. And another test is in which we will treat the sample with the ferric ammonium sulfate, due to which it will gives the green color. So it is all about the identification test and chemical constituents of the black catechu. And next drug is the Pterocarpus, which is known as the bijasal, Indian kinno tree, Malabar kinno. And if you talk about the biological source, so its botanical name is the Pterocarpus marsupium, and it's belong to family Leguminosae, and its useful parts are the stem, bark. So about the biological source, we can say that it consists of dried juice obtained by making vertical incisions to the stem bark of the plant Pterocarpus marsupium belonging to family Leguminosae. Okay, it's Pterocarpus का बॉटनिकल नेम क्या है? Pterocarpus marsupium, और इसकी फैमिली है Leguminosae, और इसका जो यूजफुल पार्ट्स होता है दैट इज द स्टेम बार्क. And we will make the some vertical incisions to collect the drugs. Okay, and if we talk about the geographical distributions of the drugs, so it is found in hilly regions of the Gujarat, Madhya Pradesh, Uttar Pradesh, Bihar and Odisha. It is also found in the forest of the Karnals, Kerala, West Bengal and Assam. And if we talk about the morphological characteristics of the drug, so it is normally ruby red in color, odor is odorless, taste is astringent, shape is angular grains, and its size may vary 3 to 5 to 10 mm. And its solubility pattern, so it is partially soluble in water about 80 to 90%, whereas completely soluble in the alcohol, that is 90%. So we can say that it is completely soluble in the 90% alcohol. And about the extra features, so the pieces of the quinoa are angular, glass tanning, transparent, breaking with the vitreous fractures. So it is fractures as a vitreous. So vitreous fracture is there if you break the drug sample. Then about the chemical constituents, so it consists quinotannic acid. The concentrations of quinotannic acids may be 70 to 80%. Others are quino red, then K-pyrocatechins, which is also known as the catechol, then resins is there, then gallic acid is there, and this quinotannic acid is glucosidal tannins, whereas quino red is anhydride of quinoin, and this quinoin is an insoluble flavophines, and it is produced by the action of the oxidase enzymes, and it is darker in color than the quinotannic acid. And these are the chemical tests of the drug. So when we will take the solutions of drug and it will treat with the ferrous sulfate, so it will give the green color. And in another test, when we will treat with the potassium hydroxide, so it will give the violet color. And when we will treat with the mineral acid, so it will form the precipitates. And about the uses, it is commonly used as an astringent in the treatment of diarrhea and dysentery, passive hemorrhage, toothache, and in the diabetes. And it is commonly used in the dyeing, tanning and printing. Then aqueous infusions of the wood is considered to be useful in the diabetes. Then alcoholic as well as aqueous extracts of hurt woods are known to possess the hypoglycemic action. So we can say that hypoglycemic effect, it is useful in the diabetes. And the cup mates of woods are available with the Khadi and Gramodyog Commission for treatments of the diabetes. So it is all about the Pterocarpus and Catechu, and in Catechu, pale Catechu and black Catechu we studied today's. And next drug is the Pterocarpus. These drugs are the tannin containing drugs. So it is all about these drugs. So thank you very much for watching this video.